I'm Keith Kelly. I teach middle school up here in Nokomis, which is Newport. I do fifth, sixth, seventh, and eighth grade integrated technology. I've been a language arts teacher. I've been a librarian, back to social studies after COVID, and then back to this integrated technology. Jack of all trades, master of none, I think. I'm doing this is for the teacher leader fellow. Basically, what they came up with is we have MLT ambassadors, but what they were trying to do is kind of get some areas that like have civics, I'm STEM, and then humanities, and a couple of those areas. And so there is professional development around that. If you go to steammakers.education, everything I've done is there. And I've gone through what I do in fifth grade with teamwork and building with cars and doing competitions. I've done sixth grade, which is the Legos and the coding. That's there. And then I have a whole website based on that too. Seventh grade, I talked about how I do skateboards and 3D printing in eighth grade. And so this one now I'm starting to do, I've done, and I have one that is more focused on the 3D modeling software SketchUp and Tinkercad. I did one on there in the Christmas time one. And this one's going to be kind of focused more on coding. A mixture, it's going to pick up some of the stuff we do in sixth grade around the Legos, Scratch, and some of the 3D in Tinkercad. I'm going to talk to you about this. Kind of started, so my brother and I did a podcast with Pender Macon, the head of DOE. And you can go listen to it. So if what holds us together is the podcast right on the main website. And if you go to Spotify or Apple, it's right on there. And there's Kern and I having the whole discussion. And we're talking about computer coding in the classroom. And they kind of got me going on this idea, talking with her about what real coding, what is there for going on for coding. One thing that kind of is interesting is we have a tendency to think that this stuff is a separate thing, that, oh, we're doing coding for coding's sake, or they're writing, computer coding. But what's happening now, and you guys probably have noticed it, is it's not a separate thing. It's actually part of their everyday life. Every time they're using a phone, every time they're doing it, they're using it. Now, there's a difference between being a user and being a creator. And that's what I'm going to talk about. We get the kids creating a little. It helps them kind of like being a mechanic and driving a car and understanding what's under the hood. So one, it gives you power because oh, I understand this a little bit. Also, no one can kind of scam you. No one can say, oh, your water pump is a quart low in oil, which isn't a real thing. So that's kind of what it's helpful to do. All right, so what I'm going to do today is talk to you about coding and how I use it in my classroom. And it ends up being two things. With my STEAM, sometimes it's officially part of the class. I only see kids for 20 classes, so I don't have a lot of time in that thing. I see every fifth and sixth, seventh, and eighth grader, but over the year, it ends up being about 20 classes. But I use the coding to actually do stuff, the robotics, the Legos, but I also do coding when it comes to not just coding. I use it as my filler. Like the problem with an IT room, a lot of times you have to do it here. I can't send kids home with my Lego kits or my skateboards or my stuff or my 3D printers. So they have what they can do outside of class sometimes is limited. So I use my coding as my that's your homework, or that's when I have a sub, something like that. I scare subs with, they don't really want to touch the power tools, anything like that. So rather than traumatize my sub, I use my coding stuff to fill that in. But it's a great learning thing. As a language arts teacher, it was interesting talking with her she was talking about how she did coding binary. I remember doing DOS. And then now the kids are doing blocky coding and some others. And what was interesting is as a language arts teacher, what I realized is a language arts teacher teaches syntax and linear order. And this is what a common story has. It's the same with coding. When you're doing a program, there's controls, there's sensors, there's variables that you put in. If we start having that language, it's not a separate thing. The kids it's been an interesting thing. We all know the kids love to play the games, right? They all want to play. They all want to go and play a computer game all the time. Now, it has changed. I thought it was interesting. When I came back from COVID, it used to be if I gave a kid's reward, they would always say, oh, let's sit at our computer and play a game. Well, now they all want to go outside. They all want to be together as a group. They actually get mad at me if we do too much with the technology that way. But you can use that I want to play a game or that filler time, that in time, and use it to teach them at the same time. So this game, Robot Island, ABCYA, and I will have this on my PD site, put all the links to all of this right there. So you'll be able to just click and it'll be right there for you. This is a game on it. If you just push play, it will play. Level 1. The game basically is doing variables. Okay, so what I do is I have the kids come in here and start playing the game. Now, there are, Amazon has a coding section, and I'll show you the CS First, which is Google's coding, prepackaged, and it uses this stuff in there. So we start with this game teaching the kids the concept of what commands, and we talk about a computer can only do exactly what it does one or three things. It's either doing what you tell it to do, or someone coded it to tell it to do, or it's either mixing those codings to do something. And I talked to the kids about glitches in the game and Easter eggs. And glitches is when you have a game that the coder playing a game that you'd run, and if you shoot something at your feet, it would take your character out. But if you went in the corner, it would bounce you. Well, if you put them together, it would bounce you in the corner. Those two code things meshed and made a glitch in the game. There's also Easter eggs where there's a special room or something that was put there by the person who coded. But we talk to the kids, they all talk about they can play computer games, but they doesn't necessarily being a user is not being a player. I mean, being a player is not being a creator. So like in games, they actually get frustrated with games because games have boundaries. Even if you go to Minecraft, there's an outer edge. There's a top, there's a bottom, there's a back, and there's a left, right? It puts you in a direction. So we talk about this with the game. So this simple game here, you have four to start with. It gives you four little directions you can go. When you click on them, you can say, okay, I want that to go there. Now, the premise of the game is when I go is I don't want to walk into the water. When I walk in the water, it makes me start going over. So the kids first learn how, okay, I got to put the basic directions of this game. And now, it's very simple to start. You're trying to get to the flag. So you can see, boom, boom, boom. So it has four variables. Now I can go to the next level, and it has four variables. Now it adds another piece. And now we got to get across there. How do I get across? Well, I only have one piece to use. And this piece shows you that if I go, it goes across the water. So I let the kids do this. They're sitting in and doing this sort of stuff. And again, you're trying to get, okay, how can I get up to this now? I have to go. And the kids, if you notice now, you keep adding more variables, you keep adding more choices. What also happens with this game that's kind of cool is it starts to be not just like simple in the sense you can see this is pretty simple and it builds as you go. Oh, and you can see I've gotten across to there. Now I'm on my next one. Now the game starts adding like, oh man, okay, I got to do this before I do this. And now it starts talking to you about sequencing of coding. So rather than like the kids will just go, oh, okay, I'll just do this. And then they'll go, okay, I'll do this. And then but what will happen is you now start to have to think about, oh, maybe I should do this before I do this. Because the 1, 2, it shows the linear part of coding. 1, 2, line first before that for the next one. And then again, they just keep playing on. Oh, and you can see, oh, like this right here, like if I did this, I have to do it. So this is, and then it's 7. So if you watch, he's going to go up, come back, go across. He's going to walk over this red and then go back up to do it. That becomes an issue of sequencing. And if I don't do it that way, it won't work. And again, the kids have to, this starts teaching them that. And then we add a new variable. Now we're adding this. This is to go and you teleport. And as the game goes, it gets harder and harder and harder and harder. Okay. So I'm letting the kids do it. They will at first go, all right. And then they'll get frustrated. And then they'll start cheating with their classmates, asking who's doing what, how am I doing it? You know, how am I getting there? But this is a good to start them, to get them to kind of understand the basics of coding. And then when we get to that 15th level, that harder level, we start talking about not only just like you have the order of operations, but also we start talking about quality of your coding. The less pieces you use, the less memory it takes, the faster it is. So instead of writing everything out, walk 2 feet, walk, turn, if you can say, do this over and over again, and that's when I lead them, and I'm going to show you blocky coding, but that's where I lead them to it. Is everybody kind of understanding that so far? Kind of the simple game to, this is a great, it's a way for them to play a game, but there is education to this. It's very simple. Some kids will fly through, other kids they'll get frustrated. The hard thing I find in my program is coming up with troubleshooting in a controlled environment. So you want them to try and it fail, but in a controlled way. And then also the repetitiveness. They will give up. They sometimes don't have a lot of grit, right? Because remember, all the games they're playing, and we talk about ecosystems, Microsoft, Xbox, PlayStation, Sony, Google, Apple, they all want you to live in their ecosystem. They all want you to buy their phone with their computer and their streaming service. Well, what they do, or these games, I tell kids, and we talk about games like, well, why is this game, why are they giving this game to you free? And the kids will say, oh, either they're selling ads, and you'll see this game has ads in it, or they'll make us pay for stuff. Like the kids all like Fortnite, and they'll pay for skins or special features to have something else later on. That's how they're making their money. They also, though, we talk about the games. These games actually are set up to get tough. And then there's a Candy Crush level. It's really tough, but once you get through it, it gets easy for like 10 levels after that because they want to keep you going. It's the biggest industry is gaming industry now. The gaming industry dwarfs movies and music industry because it's so large and so big. But what you got, I use this to teaching moment so that if I teach them that, then that power is gone from that. They understand, they see that. But this is a good little one that you have them keep going. They will give up. They will stop. And you're like, no, you got to keep trying. And then once in a while, I'll give them hints. A lot of times they'll miss the sequences. It gets a little bit harder as it goes. I think there's like 15 levels. You can add little prize or challenges. All right, so that's that one again. And I will, here, I'll put this in the chat, but I also, when I put it on my my website, I will put it in there so that you guys have it. Here's the link to that game. It does, this one has ads, just to warn you. There is a teacher, you can pay a subscription and have a teacher one. It's not, I have yet to have any ads that are inappropriate, but it does have ads, just so you know. All right, so that's Robot Island. Now we're going to move on to Spike Prime. And you can see my kids right now are building, they build the Rhino robot. And then they do the worksheet, the coding worksheet that comes with it. And then we have a challenge where I say, get closest to the edge without driving off and come back. So they learn a coding from the worksheet and then they have to try to apply it. When the Rhino's done, they move on to the bike, and the bike's challenge is who can make the bike climb the steepest incline. And again, the same thing that way. Now I use Flip to video, and I'm going to do some training on video, different ways of doing video in your classroom. I'm going to do a special training just for that. But they use Flip, they video the building process, and then they video this, the screen capture that I'm showing you, how the coding. I use them, they screen capture showing me their coding. That is a value. That is kind of a tough thing as a teacher. How do you get them to show you the coding they did? Well, I use Flip and I have them screen capture it. And I will do a whole training on video, how to do that. So in the Spike software, there's units, pre-done unit. There's the start. It gives you nice, simple tutorials that I have all the kids do. In the build, there again, the building instructions for the Rhino, the bike. So there's the Rhino, the bike is all there, and the kids, you click on it, and oh, it's taking a second to load. There'll be the step-by-step instructions are there, and there's a worksheet that goes with this. So if I go to units, let's go view lesson plans. The lesson plans are great, are really good. This is the lesson plan for the Rhino. So if I click on it, my kids, this is what I give them, this right here, this worksheet, and they do this coding. And when they're done, they'll have learned basically how to make this move and how to use the sensor. This is pretty well, I really like the stuff done by the Legos. So I'm going to hit new project. So I get a blank screen. I want to do this. So I want you to make you understand when there's coding, there are this is the 3 kind of levels of coding now. If you have an essential kid or younger grades, you can do icon based. So I'm going to click icon and create. Icon is literally, this is all it does. So it's like a picture, you drag it out and you can see it's all puzzled. So it stacks. So you can see it's very simple though, right? You have limited what you can do, but it's a lot easier to stack it in order and to have it to connect to your robot and do what you tell it to. The play, the timer, the power of the motor, what direction, how many rotations, and then what does the light matrix going to look like. Very, very simplistic. So you just literally drag and drop, but it's kind of good for the younger grades if you're kind of doing that. Sometimes it's actually kind of interesting when I have my older kids, I make them come back and try to program in this because it's so simple and they're used to the higher level. They have to figure out, how can I get it to do it when I have less options, less choice. You were talking about making your older kids push them. That's a way to do it. Click over here. There's always more. Like if you're missing some, you can click and now when I get out of this, you'll see there's even more choices that I didn't have last time. I'm going to go back out, but I wanted to show that to you because that's very, very simple. What the icon has done is instead of you having to type in and say, I don't know what you guys did, but I did TOS programming where you had, if you wanted to print something, you had to type print in parentheses and then CAT to tell it to print. And then you had to tell it to clear screen and everything. Now, what this icon base or Pitches does is it does that for you and you just say, oh, I want it to print. And then you just type what you want to print it. And all that other coding is done for you. Now, word blocks, and this is where most of the kids in middle school are, if you hit create, is now it's the same thing, but you'll see it's more like there's more stuff to it. It's still icon based, so it's still a puzzle, but now you'll see little drop downs like what place are you plugging in, how many rotations, you can, again, motors, movement, and then you get the sensors like the light sensor, sound sensor, play, so, and you can see now the kids are getting like levels. It does add another level of now you're starting to say, oh, when the program starts, do this. Oh, now I've got two programs running at the same time. And it says, oh, if the color of the light matrix, so if it sees a red brick or a purple brick or something, and what that's saying is, oh, if that sensor sees this, do this thing. So now it's if then. All of this is pre-algebra, right? All of this is looking for a variable and putting it down. And you just stack it. You'll see, like if I go back, oh, I want it. So if it sees the color, I want it to turn on and have that smiley face. Or I can go down to movement, say movement. Events are all like, do this. You'll actually start to see the kids. Again, you'll get different shapes. I'll have kids go, Mr. Kelly, what goes in there? And I said, well, let's go through and look. And oh, there's a sensor that fits that shape. Now, they will try to put a square peg in a round hole. I'll warn you on that. They will do that all the time. But so you could see, oh, you can see that circle doesn't go there. It would be in a different type of an event. I scroll down and find one that would fit that. Also, we start getting if-then statements. And we start getting repeat or do. You'll actually start getting stuff stacked. You can stack stuff inside. So you can say, oh, if it's doing red, then let me go down here. Then and this A button is pressed. And then I can go and say, oh, play the sound. Play the cat meow sound. And if this doesn't happen, then let's do something else. Let's go, or if none of that happens, go and turn the light on to a smiley face. So you start getting if-thens, and you actually have to start thinking of the controls. You have to start thinking of the events. When this happens, you can see I'm starting to make multiple blocks. Now, I haven't had to write this out. This is pre-done for me, okay? By the way, if you want to add more, so right now I've scrolled all the way down and you'll see everything's color-coded too. We'll come back to this, but if you come down, if you need, like you're missing stuff, you can actually make variables of blocks where you can come down here and click and there's a whole bunch. Oh, there's more movement, there's line graphs. If I check those off on the left-hand side, now there's actually even more stuff that I can do. This is where we start getting our if greater than, less than. So you can have the kids start to say, oh, if, so you can start to see, you can start changing your variables. So you can say, oh, if it is between 2 and it's less, it is 0 less than 1. So like the number of times the sensors hit. So this Rhino has a touch sensor on the front. You could say if this gets hit 10 times, do this. Or if it's greater than 10, have it make a, spin 12 times. If it's less than, so now tons of algebra stuff is sitting here. You could see like you're adding tons of variables there. Blocky coding is pretty good. They can kind of get it. What I find is my kids really mess up a couple things. There's a sensor, it's A, B, C, D, E, F. And what they'll do is they won't plug them in the right sensor. They go, Mr. Kelly, it's not moving. And they're like, what? And well, let's look, and this is a case of you're teaching them troubleshooting, eliminating variables. Like, so I'll say, unplug everything, but just the touch or just the motion, get that moving first. Once that's done, then we can add the touch, so we eliminate variables to get what works, what doesn't, because they'll just leave it unplugged and it doesn't work. And I don't know what you guys, but they don't really have a lot of grit. They will instantaneously give up. So you have to, try it, figure it out. This kit, I don't know you guys, but these kits, I mean, I've had my little tiny, young nephews that are, in preschool or like just out of preschool, and they can do quite a bit with them. So if the middle schooler is telling you I can't follow the directions from the Lego, they're choosing not to, because it's color coordinated. There's a video, there's step by step, the coding. That's why I do have them use that worksheet, because if you look at the worksheet gives you do this coding. So they just go back and go, okay, when the program starts, I got that piece. And then they go back to here and they say, oh, wait, stop B to A. Okay, so I'm going to go up to where the motors are, find that color. Oh, there it is. And then, oh, right here, set motors to A, B. This is where they mess up. They plugged into, it says B and A and they have it plugged in. And it'll even say, it'll say what's plugged in, what's not, and that type of thing. Now, I haven't connected a robot or anything, but a lot of two is, so all I'm going to do is I'm going to turn the robot on. Hopefully this one is charged. I have a lot of Legos. I have 1-to-1 now, which I never, when I first started, I only had 4, and then I had 8. And then I had 20, and at the start of the year with 20, I would share it with my kids. So in groups of 3, they all would use them. So I could have one class at a time. Or you can do asynchronous grouping. So you have one kid build and their classmates are in the other 2 classes. That way it quadruples your stuff. And it makes them so every kid is doing something. And like the Rhino, one kid can build the front part of it. One kid could build the head part of it. And then what you can do is the other kid does the programming of it. And then in the next robot, you flip it. So they all get a chance. But now I have 1-to-1. But then what you do, so I turned it on, turned the little blue button on so it's blinking. And then if I go to connect, I say green. And I say open, and this is 53. Make sure you label your robots. I have a 66 here. So now you can see it telling me what motor's plugged in. So so you can see the kids, again, I'll just follow what the picture, okay, movement 50%. What's the percentage is good. And then I have them all do this worksheet first so that they, right there. Now, if you go down here and I push play, you can see them now. The wheels are moving, so it did that coding. And I hit stop, and it's just process of elimination. But this blocky coding is pretty good. And again, to get a challenge, have them do these codings, and then say, create some little challenges with that robot that they kind of have to figure out outside of the coding. So they have the basics of movement, and then because then they have to learn, for my thing, they have to learn, well, how do I make this drive, stop, turn around, drive, and not hit? And if I hit it, it stops. And so you add those little challenges, but from within the worksheet that they started. Now in here too, if I go back, I'm gonna go back to home. So I'm starting new. There's a third thing you'll see. This is older kids. So if I go Python, so now you can see you're back to coding by typing. You're actually saying now the things that this is tougher to do, but you have a lot more power. So when we have a Rubik's Cube solver, it's written in Python because it's a lot harder to do. So that's another level. That would be your older kids. If I'm teaching this, what I do is take a coding I have and have them edit in Python rather than starting completely from scratch. But I just wanted to show that to you that that's that level. Other thing you do have for some coding is, has everybody heard Scratch? Pretty much. Again, free out there. MIT has made it. I do a lot where I just have kids take an already existing game and edit it. So like I will give them this Pong game. And so I'll say, okay, see inside. This is what the coding is. So this game, basically, if we play, if we watch, it's just Pong. If they hit the ball, every time they hit the ball gets smaller. So it gets harder. Makes the noise. If it hits the player, it's good. If it misses and it hits that black, you lose the game. So it's kind of like baseball. So what I'll have the kids do is, okay, play around with some of this coding. Play around with what's the coding that goes with this sprite. Sprite, basically in Scratch, notice it's the same kind of blocky coding as I just showed you. You have your play area. You have a sprite, which is anything in the game that can be interactive. A backdrop is kind of the backdrop. Usually the backdrop's not interactive, right? In this case, this backdrop has this color that if you touch it, the game loses. And then with this shows you this code. This just goes back and forth straight. If we go to ball, you can see this is the basics. If I click on backdrop, there's the other coding. It's saying, hey, if you touch that color, and I have the kids play with, say, okay, what if we took this coding and what if we change the color that it hits? So what if it hits the baseball player? So I'm going to take and change the color. Now, if we play the game, if it touches the bat, it's fine. But if it touches, oh, I picked the wrong color. Oh, I have to hit, it has to be this one right here. Let me do it again. But I have the kids manipulate a game that's already done. There we go. And now if it hits you lose the game because now you're hitting the player. So now the game changes. Oh, try to avoid getting hit. Try and have the player hit him at all. So I have the kids take a game that's already there and manipulate it. A good thing to teach Scratch with, CS First. Amazon has Amazon Engineer program, and it has videos. CS First is Google's version, so you can say I'm a teacher. What's really cool, so I'm going to go in so you guys can see in my class. You can go and set up a class. You can actually import your Google class in it, so you can create a class. You can say, okay, I'm going to import a class that I have, import it, and it will bring those kids into it, and it will invite them to it. So there's that. Where's that new? There's the new class. You can hit add units. And what's cool is you can look at stuff that's done. I have all the kids do the basic tutorial one. So I say add that. And then I'm just going to add it to there. And what happens is you can just have your kids log in, and it's really cool because it becomes a self-contained thing. So my kids go in, this basic unit is very simple, and it shows, oh, okay, start. So they start this section, they go, got it, and then it shows them how the basics of Scratch. And they go step by step, and they go and say, okay, oh, I've jumped tabs, but there's videos, there's these little cards that will take them through on hints on how to do things. I already done this, so give me a second. I just got to jump back to the beginning. And I make my kids do this to start. This is what I also assign. So then they just go and they do the coding. They follow what the pitcher tells them to do, and they slowly do the coding as they go through. And that's in CS First. That's in there. Let me go up to my dashboard. Now, that was the introduction one. If I go here and I'm going to go click add units, I can pick other units. And if I scroll through, I've got other ones. So there was, I'm going to hit add units. So I have that class I've added. I've done that one. There's characterization, there's short ones. What I do is I make my kids, I give them the game one. So you'll see this game design. So I add that to the class. And what the game design one does is, so if you have that kid that you can actually create Google assignments directly from this. I do this, if I'm out, the kids do this for the sub. So they come in, they sit, they put their headphones on, and they do it. What's really cool about this game design unit is it has all the basics of game story, a racing game, a maze game, a platform game, an escape game, a launcher, a quest, and a cave surfer. Now, my challenge is when they've gone through those, now I do that over 5th, 6th, 7th, and 8th. By the time we get to the 8th, I will go, we have Kern and I made an arcade that we have the mapping of the key of the joystick and everything. So the kids take a game and make it for them. If you get other kids playing their games, they'll kill themselves to make it a good game. They'll kill this because they don't care about you. They care about their classmates. They all think they're going to be gamer YouTubers. They all think they're going to be YouTubers and they're going to game and everyone's going to watch them. I try to tell them they're more likely to be an NFL player or an NBA player than that statistics. But these ones, I like this little unit. The kids like it. Basically, once you attach this, they start it and there's little videos to watch. There's how activities like tutorials that they do as they go. On the side, so they actually, here's the activity and here's where they code. They code in Scratch. So they have to use the blocky coding and everything, but there's no way you're going to be able to teach like all of Scratch in your time that you have. But what you can do is they do that to basic tutorial. And then what here is this video shows them what to do. And as they go step by step, it teaches them the coding in the video on what the parts they have to do. And then even there's like advanced stuff like, oh, if I want to add vector or add sounds or bitmaps. So if you have those kids that really want to fly, but what's cool is as they go, they've learned storytelling. Then they learn how to make a maze game. Then they learn how to, and it becomes a self-contained thing. What's actually too is as a teacher, so I'm going to go to my dashboard. I'm going to go into a class that I have going. If I go, so if I go to the game design, and you could see, so 8 lessons, I can, those are what they have to do. But if I actually go in and into the class, let's see, people, I can actually go and look and see what they've done. So if you units and you can see progress, so we can see, okay, who's done, I got to get a class that has actually worked on it, just a second, but you can actually see, these are the ones, that's the class I just made. Okay, let me go here. You can actually go and see like their work, did they watch? So I'm going to go units. So you can see activities viewed, projects submitted, survey results. So what I can actually do is click on the activities and see, okay, who viewed what, who did what number are they on? So it gives you a way of grading this. What are they missing? So even though it's self-contained, like the kid who's flying is flying, the kid who needs more time is more time, but it's all it shows you all right here what they've handed in. So like I had 16, these are the 16 projects that the kids handed in. The other thing too is I can literally click on the project, open it up, and look at their work. That's CS first. I like this because it's self-contained. In other words, they can kind of do it on their own, and it leads them into those parts. It has other stuff, and Art of Codes there, code.org is available, but I use this CS first to supplement my Scratch. It's still doing blocky coding. Like there's no difference in the coding because it's doing the same kind of coding that the Lego's doing. So this is kind of it's on top of each other. Like the kids are doing this coding in my class, but then they can use this as their assignment or when I am out with a sub. That you can, for higher level, Tinkercad has code blocks in it. That is, so Tinkercad's 3-dimensional, 3D. So my 8th graders, when we're creating, so I'm going to start tinkering. But we're not just creating, let me go designs, create. So I'm going to create in a code block. But the difference with this is, and I've done a video on this, instead of designing 3D objects in Tinkercad, drawing it, like grabbing and drawing out, you can, same concept, tell the unit to do it. So, and the kids will start saying, oh, I get this. I see, this is the same coding I done in my, the Lego coding. So we can say, oh, create a new object. you can go and say, oh, and scale it. Let's say have it scale to 20 size. Modify, oh, control, there we go. Repeat it. So I'm going to say repeat it 5 times. And you'll see if I play it over here on the right-hand side, it's gone and done it. So it scaled it. It scaled really giant and back so you could see. It's so big that you're seeing it from a distance. Let me go down to like scale it to 3 instead. And then I'm going to play. Now, it's not showing the 5 times because it's on top of each other, but if I say move, modify, let's see. So it's saying move to a certain X, Y, and Z axis. So I can build this up and then I just play it and run it. But the difference is like we have one that builds a rocket. So it's self-running. It's still 3D, but it's doing it. And it's also, especially with my 8th graders, talk about using coding language to do repetitive things. So if we want to make file this 3D printed object, we can tell it to do this and have it repeat, so it fills the whole plate to make us to be able to print 10 or 20 at a time. Notice we're still getting blocky coding. No difference. We're still getting some blocky coding. Is that good? Everybody good with that so far? Okay.
I have a
so
question
that's just
for you.
Yep.
What I have found in Tinkercad code blocks is there's a limitation. Like when
Yep.
I had students follow a video to build a rocket, and the rockets
Yep.
were 100 millimeters tall.
Yep.
And I did that with the hopes that when they built their own rockets, that they would be able to put that into code blocks. However, their own rockets are their actual model rockets, so they're 15 inches tall, and it won't do it.
Yeah.
It's
What
at
you're going to
100
have them do
millimeters.
is segment it. So then it would be assembled. Because I know what your printers are too, because your printers are 4 inches, the
Yeah.
binders are 4. So if you had them say, just like a NASCAR, I mean, a NASA rocket, it's segmented. Say you build it in segments. So have them build it, and then you'd print, and then it would be assembled. Does that make sense?
So, okay. So in cold blocks, could I have them build the 100 millimeter fuselage and then another 100 millimeter fuselage and say, move it up 100 millimeters?
You should be able to. You
should be able to do that way. Okay,
Yeah.
that's really
Yeah.
helpful. I'll have to let my tech coaches know that too, because we were a little puzzled on that. We were thinking that's kind of a limitation, but in
Yeah.
terms of being able to print, that actually makes a lot more
Well,
sense.
the other thing too is you could have them do the fuselage and one prints here, and then they're going to assemble it so that it's printed on the plane, but not on top of each other, because
Yeah.
you only have a 4x4.
Oh yeah, no, I
don't know where the Perloffs are working on rocket. Kern and I, so what we do is this is a tube and you use air compressor. Let me get it. And you hit it and you 3D print the rockets for launching. So you have it's practical for what the rockets have to be. But the Perloffs are starting to give this out as a grant too, just so I'll talk more about it in another session, but.
Okay, yeah, that'd be cool to hear about. Thank you.
Tinkercad just added, this is kind of a little bit like coding, but added simulations. So let me go here. So SimLab. So coding block but the difference with the coding block in Tinkercad for my kids. So if you think about it, my kids have done Scratch a little bit. They've gone and done the Legos coding. Now in 8th grade, they do the coding using, to code shapes. Again, that's starting to get into using the technology, using the code to actually have it do it for you. They do a lot, you guys know, they all do the phones and they can text faster than any of us. They can use it. Just because, and I have parents will come in, a kid can use a phone doesn't mean they can use it efficiently or ethically or, the right way. So just because you can, I can drive a car, but it doesn't necessarily mean I can be an off-roader or be a NASCAR driver. So we work with that with the kids, but this coding lets you code outside. This one's kind of cool. The new SimLab that has come out is now, like where you can actually, you're simulating things that are going on. So like a dominoes or like this marble maze. So you can copy and tinker with it. And again, we're talking about variables, and I'm trying to give my kids ways of trying things out in a, let me just rotate this, in a controlled way. So this one is all like you can simulate. So up here, there's an apple. Let me just get home. Oh, I gotta zoom out. Sorry, there we go. Then I can turn it. And this one, so if I hit this apple, it's going to simulate what would happen gravity. So you're going to actually watch. So if I push play, this is what happens. So then the kids can actually go in and manipulate these areas to see, okay, what different happens with the balls if we add more pieces and stuff. Again, adding variables, what, more steepness, less steep, more pieces, less marbles, more marbles. How could you get it to be faster? That type of thing. So the simulator is kind of a cool thing too as well. That's more kind of talking about how programming is done rather than the actual coding. Ooh. But I just wanted to add that. Now the next level with older kids, I would start getting into Python, also starting coding for a reason. Like we built that wash tables, so we had to have a code and it mattered how you code. Apps, that's a coding app challenge that's there. This is March 29th, but the Tyler challenge that the kids can do and they can get a scholarship with, but it's making something with your phone. But in the programming, there's how to use the phone is mainappchallenge.com. And I'll put this in my link and everything, but that's about web-based if you're looking for something for the older kids to do. And I'll give you this too as well, if you're interested. I use this pixel art thing. I mean, what this does is I use this to show spreadsheets, but it also is talking about coding language. Because what happens is the kids are very used to everything being done for them. So what we do is this little spreadsheet, if you look, what it does is it teaches them pixels, and it also kind of makes them understand that everything on a computer is on or off. That's the only thing it understands. It combines a whole bunch of on and offs to equal letters. So when you spell cat, it's 0, 0, on, off, on, off, on, off, and that's CAT. So, or colors or numbers. So this little spreadsheet, if you look, so this kind of a cool thing. So if the kid puts the letter J, it's that color. If the kid puts the letter M, it's that color. So I have them make pixel art. And so they go in and they play around and they fill up and create an image using this. And then we talk about, well, why is that doing it? And then we go in and talk about conditional formatting. Oh, so conditional formatting, and you can see what it's saying is if someone types the letter A in cell block A all the way down to BH30. So down here. So if you go over here and we type A, right? It changes to that color. If you do a B, it's that color. And you can see how we go all the way down. Those letters have all equaled something. If I type an X, nothing happens because X has not been given a color. So I talk to the kids, okay, let's add that rule. Let's go and say, okay, we want to apply to the same range. So I'm going to go A, BH. So I'm just copying that range. So I'm right here and I'm going to go and say cancel. I'm going to go all the way to the bottom. I'm going to add a rule. And I'm in Google Spreadsheets right now. And I'll give you this file if you're interested. I can share it with you in a second. So A1 to BH30. And I say, okay, if text is exactly, and I say X. And then down here, I can say, okay, let's make it be a color that isn't in the choice. So let's see. Is like, oh, yeah, no, neon green's used, teal's used, pink's used. Let's say, okay, so this really dark magenta isn't. Okay, so if I say done, now if you type X, you can see now there's an issue. You can see the letter X shows up because what they did with these, when we click like the T, it said, oh, if the letter is the same color as well. So I have to talk to the kids. Oh, you wanted to add? Okay, you not only have that, you have to say, oh, the letter changes color too. So now you can see there. And the kids will sit and play and make their own pixel art. And that helps them understand that every time you go on a website, every color is a set numbers of some zeros. But again, there's coding in that. I got this from Eric Kurtz, Control Alt Achieve. He has some really kind of great stuff. He's a great, I've met him. He's a presenter and stuff, and I've met him and stuff. But if you go resources, you can look through and like Google Sheets. He's made a bunch. So like there is the templates. Let's see. Yeah, 26. If you click this, this is make a copy of it. This is the same thing that you had. Now he's added, I just made it pixel because time-wise, I don't have time, but he does it with fractions and he adds some more areas too. But, and again, I'll give you this copy of this. So this is where I got it. I know him personally, so that's how he gave it to me, but it's on his website. And if you're interested, it's kind of a cool place. Oh, I got to go over here to give it to you. And I'll link all of this in my PD when I redo this again. I like to use this because it's a great way for my kids I use it to teach spreadsheets too, because then they understand row and column. He actually has Battleship in here. I can't remember where it is, but there is like how to teach. See, there is a Battleship in one of these too that he has that's pretty cool. So the kids play Battleship using, what I would do is breaking the code down. So you can either use Scratch, you can use the Lego Spikes software, you can use your Tinkercad. I'm trying to give you some free stuff. So if you don't have that, there are tons of game stuff that's higher level, Unity Player, things like that. And the kids are doing this coding already. Even we'll have complete discussions about the games they're playing. And we'll talk. I try to focus more on how the gameplay is done. How does what are they playing? Like the Mario Kart they're playing. How does it understand how to interact with these other characters? Like what limitations? And we talk about how the game limits you, how it saves memory by playing little movies rather than letting you see the whole thing on introduction. And we talk about the limitations and how to exceed. And what that does, this is the state, this is the Drupal. If you click professional development, here are each, like this is what I do in 5th, this is what I do in 6th, 7th, 8th. I've added, I'll add my next one, the one I'm just doing now. I'll probably put the coding in with this section so that it's there. But if you click on any one of them, so you click on this one, if you go down, everything I've done, the video is there of me going over it, the slideshow, if I've done a slideshow to go with it. And it kind of breaks down what I'm doing. If you like, oh, I can't remember because I talk fast. I know. I apologize. I am building the curriculum so you can kind of see, this is what I'm trying to create. But if you go down, I'm breaking the curriculum down by as I add to it. This is what each grade's doing, that type of stuff. I do a newsletter you can sign up for, and I keep posting and kind of talking about like this is kind of focusing on what we're doing now. I probably will do some AI stuff. I have been building a resource section. So grants that you guys can find if you're interested, placed a contest. Oh, resources like the main workforce that gives out free fund. I was able to get all my teachers a free printer last year and they took a class. They changed it. They're doing a percentage of it, but and then some cool stuff I like I like Adam Savage's Tested. A great book is Adam Savage, Every Tool is a Hammer. Kern and I just were on Cool Tools tonight. That's Kevin Kelly. And we both were on it before. And then Kern just did it again. He actually is talking about the rocket launching system that we just did. But I'm hoping this becomes a clearinghouse for you. If you want contact information from me about, that's all about me. If you're interested, but I am going to keep building up, and this video will be linked right like here in PD number 5, it will be linked and you'll be able to click on it. And when you click on it, it will open up and it will be broken down, the sections and anything that I can add to it. Any questions that I can try to answer? Hopefully, I hope hopefully this was helpful. I know it was pretty quick. The Lego stuff is the video and the lessons are really good. I have a whole video series around that and step by step. The Tinkercad stuff is cool and Scratch is really good. I recommend the CS First. Google has CS First. Amazon has an engineer program. It's very similar to the Google series. Literally, there's a video section. It does Robot Island. That's where I found it. It goes and does have videos. It teaches, breaks it down. You can sign up for that for free. They're trying to get as many coders as possible. The next thing with coding is going to be AI. You now can go out to AI and say, I want to have my web page. You guys have all gone to web pages and see it like have cool sliding pictures and stuff. You're like, how did it do it? AI, you literally can go and ask it to give you the code so you can steal the code and put it in your page. That's what's coming, where the kids are going to sit. It's going to be, that's why knowing the syntax is very important. There's tons of AI art out there where people are making it, but it looks wonky and weird because you have to tell the computer what to do. If you don't, it doesn't work right. And the same thing is happening with coding. If you have an idea of how coding works, that's gonna be the future. You're just gonna say, you can see the blocky is a lot easier to do, and that's gonna come to the point where you say, I'm gonna have to stop kids from saying, Mr. I want my Rhino to do this, this, and this, and it just does it for them. But robots will rule us all. Thank you guys very much. If you have any ideas of something you wish I would do, or even more detail, if you're like, hey, this was great, but could you, like the question you asked, I'll look a little bit into it to ask my brother. He might have a trick with that too, of the rocket, the sizes. But if you have anything like that, give me a heads up and I will try to add it to it. Any questions? Any answers? Thank you guys very much for coming. Hopefully this was helpful to you. Yeah, and I will see some of you later. I'll be doing another one every month. So I'll email you out and reach out to you once a month. I try to do it. Well, February vacation is probably after. I try not to mess your holidays up. So I'm trying to, that's why this one's a little bit later. Christmas I did try to do it way before, so it wasn't. So I'm trying to do once a month, and it will always be on that site. Thank you guys so much.